Okay, we're going to be looking at graphing nonlinear systems. And the nice thing about this particular topic is it's actually going to review a lot of other topics. So it's a good thing and a bad thing in the sense that you need to know your other topics to be able to do this, but at the same time, if you are struggling with it, this gives you an opportunity to see at least some more examples. So it's really important that you know your parent graphs. So remember, we have y equals x squared, x cubed, 1 over x, 2 to the x, absolute value of x, and the square root of x. So you need to know all of those shapes in order to work with these problems. Because you're going to be doing inequalities, and you have to worry about, first of all, graphing it, and then finding the correct area to shade. So if you don't know your parent graphs, then it's going to be really hard to do your graphing. Likewise, if sometimes you'll be given a graph and you have to figure out the equation. So you got to be able to recognize a parent graph. So now we're going to look at some inequalities and look at the parent graphs associated with them. So we can see that the parent graph of this one is a parabola. You can see that nice shape. So I know this is y equals x squared. It's solid, so I'm going to have equals. Now, whether it's a greater than or less than, you look at, is it shaded above the graph or below it? Less than would be below it, down all in this area. Greater than is above it. Like think rain coming from above, it would fill this parabola. So this is an example of y is greater than or equal to x squared. If we look at this graph, well, we should recognize my parent graph is y equals x cubed. See that nice little twist there. It's dashed, so I don't have equals in my equation. This one over here had equals. You can see the equals here. This one's not going to have equals. Okay, and if you look at it, think about rain coming from above. It's shaded below it. Now, if you're not sure, you can always test a point to make sure it works. But this is an example of y is less than x cubed. So if I want to test something, I just simply choose a point that's either true or false and make sure it works. So if I plugged in the point x equaling 2 and y equals 0, for example, this point right here, I would have 8, and then I'd have 0 for y. So 0 is less than 8. That's a true statement. I have shaded the true side. But usually above and below is going to work pretty well with these. But if you're not sure, you can always test. Okay, this one's a little weird. This is y equals 1 over x. I can see the graph. It's not dashed. I do see a dash, but that's the asymptote. The shading is below the graphs. And it looks kind of weird, but this is what the graph of y is less than or equal to 1 over x. Okay, another challenging one we've had is y equals 2 to the x. So here's 2 to the x. My shading's above it. I have a dashed line. So this is the graph of y is greater than 2 to the x. Notice it's shaded above the graph. So it's a greater than. We have to have it in this format where y comes first in order for the above and below idea to work. Okay, let's say we're given the equation. Now we want to sketch the graph. So I got y is less than or equal to the square root of x. Well, first I'm going to look at just y equals, because I have my equals right here. So here is the graph of y equals the square root of x. Well, I want the less than part of it. So now I see the less than, that determines the shading. Well, it's going to be below the graph. So below this graph is straight down below right here. Nothing shaded over here because you can't, for graphing, we're not going to be able to do square roots of negatives. You're not going to be able to graph complex numbers. Okay, another example. Y is less than absolute value of x. Okay, so let's see about first sketching the absolute value. Now it doesn't have equals, so I'm going to make the absolute value with a dash. So that's that V shape. Now my shading, less than, is below it. So it should be all down in this area here. Okay, so it gives you an idea. Just work with parent graphs. Now, you want to make sure you recognize your general forms and their transformations. So remember, A is our stretching factor. Sometimes we have to do a little bit of solving for it. Watch out when it's negative with the flip. K is going to be shifting the graph up or down. And then H shifts our graph left and right. So just kind of being remember about our forms. Remember, things in parentheses work opposite. And when working with just X, that's X is left and right. K goes with the Y value, which is up and down. Okay, let's don't forget about circles though. So we look at this circle, and the general circle centered at 0, 0 has the equation x squared plus y squared equals r squared. Now in the problem over here to the right, my radius is 5, so this equation would have been x squared plus y squared is equal to 5 squared, or 25. So it's centered at not the origin. It's centered at the point HK. I should cross this part out. It has the equation x minus h squared plus y minus k squared plus rm is equal to r squared. Notice they're both in parentheses, so they can work opposite. So this is going to be shifted to the right h and up k. So when I look at my equations, or I go to figure out my equation, I'm going to use the idea of working with the opposite. So if I'm going to find the equation of the circle, I'm going to first find its center. So I'm going to kind of draw in my diagonals. There's my center. So my center is going to be at 3, negative 1. My radius, well, I went up 2, 3, 4. My radius is 4. So now when I plug it into my equation, it's going to be x minus 3 squared plus y minus negative 1, or y plus 1 squared, is equal to 16. Okay, let's look at what happens when we have inequalities though. With inequalities, let's say I have x plus 2 squared plus y squared is less than or equal to 9. Well, I've got a circle which has a center at negative 2, 0, and my radius is 3. So negative 2, 0, radius of 3. I have the equals, so it's solid. I can't use above and below here, but it's more about inside and outside. Okay, this is less than or equal to 3 squared. That's my radius. So if I'm shading everything that has a radius that's less than 3, it's on the inside. So a less than will mean I shade the inside of the circle. A greater than, I'll shade the outside. Let's say I want to find this equation. Well, first thing I'm going to do is find my center. My center is at 2, negative 1. My radius is 2. So it's x minus 2 squared plus y plus 1 squared. And then the shading is outside the circle. I have a dashed line, so I don't have equals. Greater than, outside. So less than, shade the inside. Greater than, shade the outside. Okay, so let's put the pieces together. So when you see a problem like this, it may look extremely complicated because there's so much stuff going on. You just got to take it one step at a time. So the first one I'm going to start with is this blue graph, and you should recognize that's our absolute value. So I'm going to start with the absolute value graph, and I'm going to think about what the equation of this is. Well, I can see it's flipped. I can see that it's right 1 and up 4, but it's not quite like a regular absolute value where it's going at perfect 45 degrees, but it's an easy way to find your A value. Take from the vertex. I have a negative slope, so I'm going to go down. I went down 2 and over 3. There's my A value. So it is y is equal to negative 2/3 absolute value is shifted to the right 1, so it's x minus 1, up 4, so plus 4. Now, I got to think about, well, is this going to be, it has equals because it's solid. Do I put a less than or do I put a greater than? So now I look at where the shading is. Above it, there's nothing shaded. Below it, oh, I got shading below it, so it's going to be a less than or equal to. Next graph I'm going to look at is this graph, the one that's in red. That's y equals 2 to the x. Okay, we're not going to put any A values on this one, so we just got to think about how it was shifted. So when you do an exponential, you want to think about your shifts up and down first. So I look for the asymptote. There's an asymptote right here. And that tells me it was shifted down 4, so I know it's going to be minus 4. Then I look for where does it go 1 point above. This tells me it's right 1. So I get y is equal to 2x minus 1, whoops, x plus 1, so it's opposite, to the x plus 1, then I went down 4. Now, the shading is above the graph. See, the shading's above the graph and not below the graph. This would be a less than, it's above it. So this has to be a greater than or equal to. Now we're going to work with the circle. So my circle, well, I've got to find my center. My center's at -2, -1. My radius is 3. So that means for the circle, if it was an equals, I'd have x plus 2 squared plus y plus 1 squared is equal to 9. Now, I'm not going to have equals because it's a dash. So we won't have equals here, and I got to think about the shading. Well, it's shaded inside the circle. Inside the circle is a less than. So my final solution is all of this. Okay, so that's just kind of piecing it. Just take it one piece at a time. Just do each individually, and you'll be able to work through the process. Okay, next problem. What if you have to draw it? Well, again, what I'm going to do is do each piece separately. So right here, I've got a cube, and it's flipped over. It's going to be going to the left 3 and down 2. So when I go over, I'll have left 3, down 2. There's my locator point. And a cubic is flipped over, so it's going to do a reverse twist like this. Now I'm going to think about how the shading is going to go. It's greater than. So right now, when I'm thinking about it, I know it's going to be kind of shaded above this area. That's the above. This would be below. This is above. Okay, so I'm just going to kind of concentrate. I'm not going to fill in everything, but I'm going to get a rough idea of what it looks like. Okay, now I'm going to go to this graph. We have an absolute value graph. It's shifted to the right 2 and up 6. So I go right 2, up 6. That's that point right here. And then I'm going to use my A-value, so I know it's going to be flipped over. I'm going to go down 1, backwards 2. Whoops, I put my point in the wrong spot. Shoot, it should have been over here. So I'm going to change this equation because I just realized my graph was wrong. So we're going to make it up 1. So it should be x minus 1, because I got all my shading and everything else all done, plus 6. Okay. Then I have another one that's going to go down 1 over 2. And the shading for this one, if I had y is less than, the shading for this one is going to be below it. So now I'm looking at this area. Now I'm not going to worry about this stuff. So now I know it's somewhere in this section. Okay, so right now we're going to bound it within these two areas. Now, y is greater than 3/4 x minus 1. Well, I'm going to start at -1. It's just a regular line. Go up 3, then over 4 is dashed. So there I have my line. I'm shaded above it. So my final answer is going to be above that one. So now I'm looking at this little region in here. There's my final solution. Okay, hopefully this helps out. Sorry that I had that the absolute value one not in the correct spot, but it should have been x minus 1 plus 6.